Element 5.2. Vibration. In this session, we will specifically address hand-arm vibration and whole-body vibration, aiming to identify their potential ill health effects on the human body. Hand-arm vibration syndrome, HAVS, is a collection of health issues resulting from prolonged exposure to vibrating tools. Symptoms may include vibration white finger, blanching, where the fingers turn white and numb due to restricted blood flow, nerve damage, leading to tingling and loss of sensation, muscle weakening, affecting grip strength, and joint damage. Whole-body vibration, on the other hand, can cause damage to spinal discs, resulting in back issues, vertigo or dizziness, and muscle weakening. These health effects underscore the importance of effective control measures and health surveillance in occupations involving exposure to hand-arm and whole-body vibration. Employers must prioritize measures to minimize the risks associated with these types of vibrations, ensuring the well-being of workers in environments where such exposure is prevalent. To assess exposure, you may need to estimate actual vibration exposure. This could be done using vibration emission data from the supplier or manufacturer of the vehicle or equipment. To understand vibration measurement, it is worth looking at the nature of vibration. When an object vibrates, it is rapidly accelerating. It means it is quickly changing its speed and/or direction. In simple cases, you can think of it as the object oscillating about an equilibrium point, accelerating first in one direction and then back again. Equilibrium point is the point where it would sit if it stopped vibrating. Real objects can oscillate in different directions, all at the same time and at a range of frequencies. When measuring vibration, there are three basic parameters. The first one is vibration magnitude, and it refers to the amplitude or strength of the oscillations or movements associated with vibrations. It is a measure of the extent to which an object or surface moves back and forth, typically measured in terms of displacement, velocity, or acceleration. In the context of health and safety, vibration magnitude is a crucial factor to consider, especially in assessing the potential impact on individuals exposed to vibrations, whether through handheld tools, machinery, or vehicle operation. Understanding and measuring vibration magnitude is essential for implementing effective control measures to mitigate the health risks associated with prolonged exposure to vibrations. Second one is vibration frequency, which is the number of oscillations or cycles per unit of time, typically measured in Hz/Hz. In the context of health and safety, it represents the rate at which an object or surface vibrates, influencing the potential health effects on individuals exposed to vibrations, such as hand-arm or whole-body vibration. And finally, vibration direction. Vibration direction refers to the path or orientation of the oscillatory movement in a vibrating object or surface. In the context of health and safety, understanding the direction of vibrations is crucial in assessing potential ergonomic risks and the associated health effects on individuals exposed to hand-arm or whole-body vibration. Vibration control involves implementing measures to minimize or eliminate the adverse effects of vibrations on individuals. One key strategy is to reduce the vibration at its source, which can be achieved through elimination, substitution of equipment, regular maintenance, or modifications to the work processes. Another approach is to interrupt the transmission pathway, and this often involves isolating the vibrating source from the worker or using vibration-damping materials. In addition, protecting the receiver, meaning the exposed individual, includes reducing the time of exposure to vibrating equipment and conducting health surveillance. Health surveillance involves systematic and regular assessments, such as audiometric testing, to monitor the health of workers who are potentially exposed to vibrations, ensuring that any adverse effects are identified and addressed promptly. These control measures collectively aim to create a safer and healthier work environment by mitigating the risks associated with vibrations. Health surveillance, particularly when conducted at or above the exposure action value, plays a crucial role in monitoring and safeguarding the well-being of workers exposed to vibrations. It enables the identification of individuals with pre-existing vibration damage, as well as those who develop new damage due to exposure. By pinpointing such cases, health surveillance facilitates the removal or exclusion of affected workers from vibration sources, preventing further harm. Additionally, this process allows for the investigation of vibration sources to address and rectify any problems contributing to the health risks associated with vibrations. Overall, health surveillance is an essential proactive measure to manage and mitigate the potential adverse effects of vibrations on workers' health.